Okay, so we'll get started now. We're going to have a look at what's called improper partial. Oh, wait. Turn the Wi-Fi off. Fractions. So last time we were looking at. Partial fractions. They were all proper, which means the denominator was a power higher than the numerator. So an example of proper was a linear, say, over a quadratic or whatever. Okay. Improper is when the power on the top is the same or greater than the bottom. So here's some examples. You could have a quadratic over a quadratic, or maybe you had a cubic over a quadratic, things like this. In other words, if the degree of the top is greater than or equal to the degree of the bottom, that's called improper. So they're a little bit harder, but not much harder. They just have one extra step. Can I scroll down? Yeah? Yeah? Okay. Okay, so let's say we have something like 2x cubed minus 7x squared minus 14x minus 23 over x squared minus 4x minus 5. And we want to find the partial fraction here. So the first thing we need to do is to simplify it. So we'll try dividing. That's what we'll do first here. So just on the side here, x squared minus 4x minus 5 divided into 2x cubed minus 7x squared minus 14x minus 23. Okay, so the first one's obviously going to be 2x, isn't it? 2x cubed minus 8x squared minus 10x. I subtract, and what do I get? X squared minus 4x, yeah, minus 23. So the next and final piece must be a 1. So that's x squared minus 4x minus 5. I subtract, and what's that leaving me with? Minus 18? Yeah. Now that's not a mistake. There is a remainder here. So let me just draw a line here. Okay, so here's the trick. Suppose, for example, I said 25 divided into 106. That goes 4 times, and it gives me a remainder of 6. You have 6 left over. Okay? Yeah? No, not quite. So if you look at this, you could say 106 equals 25 times 4 plus 6. Okay? So in other words, if you divide, let's see, I don't know, P into Q, let's say goes T times with remainder or, you're allowed to say Q equals PT plus or. In other words, what I'm saying is this cubic, you would be allowed to say it's equal to this quadratic times this linear plus, yeah, well, minus 18, yeah, plus the remainder. And that would be useful. That would be very useful now for simplifying. So in a moment, I'm going to go back to the main question. So I'll just give you a minute to write this long division down. Got that? Can I scroll back? A beer? Yeah, are you sure? Okay, so if we look back at the main question, this cubic, I can now replace it with x squared minus 4x minus 5 times 2x plus 1 minus 18 over x squared minus 4x minus 5. Now you might say, well, what was the advantage in doing that? Because now the top looks more complicated than the bottom, but we can see now in one moment there's an advantage. What I can do is split this into two problems. X squared minus 4x minus 5 times 2x plus 1 minus 18 over x squared minus 4x minus 5 over x squared minus 4x minus 5. Now I hope you can see what happens in the first fraction. That cancels with that. So what we're doing is we've changed our problem here into this problem. 2x plus 1 minus 18 over x squared minus 4x minus 5. Now we like this because this is already quite simple. And we know how to simplify this. We need to look at the fractions, the partial fractions here. So what I'll do is I'll just put the minus 18 on the top like that. Okay, and I'll split this up into two. What is the factors here? Minus 5 and plus 1. Okay, so let me just replace that there. It was the same as x minus 5, x plus 1. Okay, so let's use the cover-up method. So that'll be the easiest one here. If I want this numerator, I'll have to cover up x minus 5 and sub in 5. 5. Yeah, so that would be minus 18 over 6, which is minus 3. And then I'll have to cover up the x plus 1 and sub in minus 1. So that's minus 18 over minus 6. So that's 3, isn't it?
Yeah.
Oh, that wasn't so much different. We've managed to change this.
So there's an issue with your sign.
Do I have it the wrong way around?
Yeah, where did the negative go in the last part?
Let's try this again, sorry. If I covered this...
No, that's fine.
Oh, okay.
Like, minus 18, where did the negative on it go?
Was it not minus 18 over minus 6?
Yeah.
Which is 3.
Yeah, but I'm saying 2x plus 1 is not multiplied.
2x plus 1? My handwriting must be really bad. This
No. The last line, sir.
the last line.
Yeah, this you don't have a sign next to 2x plus 1.
Oh, here?
Yeah.
Oh, okay, there.
That's what I'm saying.
Okay, there, sorry. Right. So that's the answer. Now that's a heck of a lot nicer than the original, isn't it? Because the original was a cubic over a quadratic, and we've simplified it into a linear, constant over a linear, constant over a linear. So it's much easier to deal with this guy now than it would have been to deal with that. So we've successfully simplified it quite a lot. Okay, so that's a good example to get started. If you write that down, we'll have a look at another one now. Do you have that? Yeah? What's wrong, guys? Yes? I used the cover-up method. So what you do is you cover this up and then you put in x is 5. That gives us it's method 3 from last week. And that gives us the minus 3. And then you cover up the x plus 1 and you sub in minus 1 for x, and that would give us this 3. So this is using method number 3 from last week. Okay, you got that written down? Yeah. Yeah, yeah.
Can you please go a bit to the last?
You want the long division?
Yeah, I have a question about that.
Yeah,
So you wrote it as Q equal to P plus
Yeah.
R, and then you continue to the right side.
yeah, yeah.
Why didn't you just write it as T plus R over T?
So again, sorry, T equals?
Q is equal to T plus R over P, and then you just skip like two or three steps.
You can, yeah. Just for my first example, I wanted everything laid out clearly. But if you wanted to in the exam, skip to that. It's no problem with me. It's just for the first example I was more explicit. So you're saying just basically skip a step or two here. That's fine, yeah. Okay, do you have this written down? Yeah? Let's have a look at another example now. Okay, so let's see. Let's do C as an example here. Okay. 162x cubed plus 3x squared plus 170x over 81x squared plus 126x plus 49. Okay, so we know the story. We have to do what we did before, which is long division. So let's just dot on the side here. Right, let's see. Whoops. So that would be 81x squared plus 126x plus 49. I think I've left not enough space here, unfortunately. What was it? 81x squared plus... Yeah. Okay, that should be enough space. And then this was 162, and then 333, and then after that 170.
170.
Just like that.
Yeah.
Yeah. Right. Is the first one 2x?
Yes.
Yeah. 162x cubed plus 125, 254, 252 x squared plus 98x. And then when I subtract, they go, that's a 81? 81x squared plus 72x. So the last guy has to be 81. 81x squared, right?
Should be 1.
Oh, sorry, what am I saying? Sorry, of course, 1. 81x squared plus 126x plus 49. So 72 minus 126. Minus for sure. Minus 54x plus minus 49. Okay. Top minus bottom. Yeah? You minus the two lines. Yeah. Okay, so if I return back to the question here, we can say this is 81x squared plus 126x plus 49 times 2x plus 1 minus 54x minus 49 all over that quadratic we had at the beginning. So you know the story, just like in the last one, you can split them into two and divide each one. So the first piece will become what? 2x plus 1. And then that's all okay for us. And then the next piece will be plus minus 5x minus 49, yeah, over this quadratic. Now, I think this quadratic has repeated roots, I think. Sorry, minus 54, thank you. Is this repeated roots? Is this 9x plus 7? I think it's that, I think.
Yes.
Yeah. So this is equal to 2x plus 1 plus some number over 9x plus 7 plus something else over 9x plus 7 squared like that. Yeah? Well, I think we can get away with using the... Well, this definitely has to be a constant, right? And I think this is either bx or you could just say it's b. I think it's possible to do this here. The reason I like that is because then I can use the cover-up method. No, it's a bit messy, isn't it? No, actually the cover-up method wouldn't work here. Right, okay. I'll just call it bx, and then what I have now is this thing here.
You could use
Sorry, Mo, can you see okay?
Yeah.
What's it?
You could use the cover up method if you suppose it.
Could you? No, I can't see how, because the problem is the 9x plus 7 is in both. You can't, if you cover up the 9x plus 7, you would have to cover it up in both, because it appears in both.
Keep it as a quadratic.
Which?
Don't factor it, keep it as a quadratic.
This?
Yeah, and split it.
How do you mean?
Like put minus 54x over the quadratic. It might not work for the minus 54x, but it will definitely work for it.
I can't see how this would work at all. The problem is, suppose I want the a, I would have to cover up 9x plus 7. And if I want the b, I'd have to cover up 9x plus 7. There's no way to tell the difference between getting a and b here. It doesn't work for this one. It doesn't work for this one. I can't even get a or b. So I'll have to use method 1 or 2. Let's use method 2. Minus 54x minus 49. Would people be okay if I just jump to after the step after we multiply by the denominators? So what you remember in method 2, what you do is this is equal to this, and then you multiply everything by what here? The denominator, yeah, which is 9x plus 7 squared. So you would get minus 54x minus 49 equals a times 9x plus 7 plus bx. Right, well that's actually not so bad, because clearly if I put x equals 0, I can get my first value. I'll get a. That'll be minus 40, so a would be minus 7, I think. It would be minus 49 over 7. Okay, and what would be a nice way to get b? I could put x equals minus 7 over 9. So that guy goes, and then b would be whatever, minus 42 minus 8 over something, I've lost track of it in my head. Minus 54 times minus 7 over 9 minus 49 over minus 7 over 9. Yeah? 9 goes into that 6 times 42. 42 minus 7. 7's cancel. Is it 9?
6.
Let's see.
I got 60.
Come on, guys. Don't make me seem so much faster on the calculator. I'm really not that smart.
It is 9.
It is 9?
Yes.
Okay. So, we have minus 7 and 9. Okay. Now, Safra, come on. Yeah, but don't talk when I'm talking. It's rude. Thank you. Okay. Can I scroll back? You got that? Yeah. Okay, so minus 7 and 9. So now I can return to this, and I get my final answer. 2x plus 1. What did I say a was? Minus 7? So plus let me make that a bit neater. 2x plus 1 plus minus 7 over 9x plus 7 plus 9x over 9x plus 7 squared. So we've managed to get to the answer here. Is this okay so far? Yeah? So do you notice we're really not doing anything much different to what we did last week, except for one extra step, which is the long division. Okay? So I think it's enough just to do one more example, but we'll do a long example, or a longer example really.
Can we do one with the same degree?
Oh yeah, same on the top and the bottom.
Yeah.
What ones are those? Like
S, T, R.
H is the first one, is it? What's the first one where that happens, Mo? H, isn't it?
No.
Yeah. Oh no, it's not. Sorry. What is it?
S.
S. Okay, let's look at S then. Can I scroll down? Right, so let's just write 7x cubed minus 25x squared plus 15x minus 13 over 7x cubed minus 19x squared plus 31x minus 15. Same deal as before, except the long division will be quite interesting here because we're dividing a cubic by a cubic. So let's just take that on the side there. Yeah, you can see already what it's going to end up being. 7x cubed minus 19x squared. Oh, that's not enough space even. 7x cubed minus 19x squared plus 31x minus 15 divided into 7x cubed minus 25x squared plus 15x minus 13. So what is the first and only term? 1. 7x cubed minus 19x squared plus 31x minus 15. Divide, cancel, minus 6x squared, minus 16x, is that right?
Yeah.
Plus 2. So that means the numerator, I can write it as 1 times the cubic plus that remainder, minus 6x squared minus 16x plus 2. Plus 2. All over that cubic.
Close the brackets before the minus 6.
No, it's okay. It's okay. This is okay. There's no problem with this. It's 1 times that plus the remainder. There's no problems here. I didn't bother with the brackets because I'm multiplying by 1. So I can leave it like that. I'll still split it into 2 though.
Why don't you simplify the 2 and minus 15 before that?
No.
Sure.
Oh, well. No, because is there anything that's going to cancel the 7x cubed on the top? No, so you're still left at square 1, which is improper. Yeah.
Just go
Probably
back to
get
where
that,
you were.
yeah.
Oh yeah, of course, we just go back to the previous step. So if we split this up into 2, we'd get 1 over the cubic. No, sorry, you'd get 1.
Plus
1 plus minus 6x squared minus 16x plus 2 over the cubic. 7x cubed minus 19x squared plus 31x minus 15. Right, we've seen this guy before. It's proper. Using your calculator, what are the factors here of this cubic, please? So the factors are so what's the first factor?
7x plus 5. Oh, sorry, 7x minus 5.
Okay, and the next one?
Using the complex number.
Yeah, so they're
Yeah, they're both they're actually both
yeah. There's only one factor here. What does that mean?
divide.
Divide. To get the quadratic. Yeah. So when you're ready, I'll scroll to the right. Yeah. Okay, can I scroll to the right? Yeah. Right, so we know the deal. We'll have to do 7x minus 5 divided into the cubic to get the other factor. So the first one here is obviously a x squared. 7x cubed minus 5x squared. Subtract, and what's that? Minus 14x squared plus 31x minus 15. Right? So the next one has to be minus 2x. Minus 14x squared plus 10x.
Yes.
21x minus 15. So the last one has to be a 3, which is perfect. 21x minus 15, remainder 0. So the other factor here was x squared minus 2x plus 3. Mo, when your calculator factorizes cubics, would it give the other factor if it was a quadratic?
Yeah.
It would?
Mm-hmm.
Handy. Yeah? Can I go back to the main question? Daniel? Yeah, okay. So, let's see. Right, so now we have 1 plus, and then it'll be something over 7x minus 5, plus something over x squared minus 2x plus 3, because they're the two factors of this cubic. Well, it's clear what the first one must be. It must be a constant. And the second one must be,
Linear.
yeah, what form?
Bx plus
Bx.
c.
Yeah, it has to be bx plus c. So, this is another side problem. We want to split that guy up into these two. So, you know the process, we multiply by the denominator. So we end up getting minus 6x squared minus 16x plus 2 equals a times the quadratic, x squared minus 2x plus 3, plus bx plus c times 7x minus 5. Okay, what shall we choose first? I think if we were to choose x equals 5 over 7, that would be quite good because that would give us a. We'd get a equals minus 6 5 over 7 squared minus 16 times 5 over 7 plus 2 over 5 over 7 squared minus 2 times 5 over 7 plus 3. So that is the A. So when you're ready, you can give me the A. We got it yet?
Minus
Minus
6.
6.
Minus 6. Okay, what would be a good value to get the, what would be good value next for x?
2.
I think 0 would be good,
0.
because then what you can do is this piece is gone, and you would have minus, you would basically end up getting 2 equals 3a, which is minus 18, plus c times minus 5, so that's minus 5c. So that means you'd get 20 over minus 5 equals c, which is minus 4. Okay, and then any value will do to get the b. I think 1 would be good. So minus 6 minus 16 is minus 22, plus 2 is minus 20, equals 1 minus 2 is minus 1 plus 3 is 2 times a is minus 12, plus c, which is minus 4, plus b plus c times 2. Okay. So take that over there. Minus 8 over 2 plus 4 equals b. b 0? B is 0. Yeah. So we have a is minus 6, b is 0, and c is minus 4. Yeah, we can go back to the main question. Yeah. So, no. Yeah. Guys, now look, the four of you, my attention is drawn to you every couple of minutes. So the next time it's drawn to one of you, I'll just ask you to leave. Because you're in the middle of the four of them. You sat in the wrong place, I'm sorry to tell you this. Okay, so if my attention is drawn to the four of you, I'll ask one of you to leave because it keeps distracting me. Now, what is the a, did we say?
Minus 6.
Minus 6 over 7x minus 5 plus, and b we said was 0.
Yeah, and minus 4.
Minus 4 over x squared minus 2x plus 3 then. Okay, so, yeah, well this was quite tricky. We managed to eventually simplify this into this.
Is this an exam question though?
It would... it's been a very, very long time since they had one as difficult as this, and it'd be something like 12 marks.
So you have time, yeah.
Yeah.
12 marks, you know.
Without the integration or with?
No, with the integration it'd be like 15 marks or something, or something like this, or maybe 20 marks. I'm not sure. So no, they haven't asked it recently, not in the last 3 years, and I don't really imagine that it's likely that they will. But you see, the problem is it depends on who writes the exam, and the person who writes the exam changes every couple of years. So whoever's currently writing the exam has not put it in their exam, and they've been writing it for maybe the last 3 years.
So
It's unfortunately, their policy is the exams are supposed to be consistent each year, regardless of who's writing it. But this isn't reality. In reality, you can tell when the author changes because the style of question changes. You know, so they make the point that each exam is not supposed to reflect the author and is supposed to be consistent each year. But I mean, that's not. When you look at the past exams, you'll see for yourself. It'll be one style of question, and then all of a sudden the next year it's a different style. And you'll notice for the last 3 years it was a different style again. Now that's kind of good for you because the person who currently writes the exam, he or she doesn't put down these types of long improper questions. At least not yet anyway. They kind of prefer shorter ones. Yeah.
The person who wrote the end of semester this year,
I think
they
it's the
write
same.
the
I think it'll be the same person, because usually what happens is they write both these exams at about the same time, and they usually get the same person, and not always, but usually. Okay. Right. Have you got this one written down? Yeah. So I think what we'll do is I'll let you try these for a couple of minutes, and then we might have a talk about the coursework too. We could have a look at what's involved in it. I think that would be good. So if you could try a couple of these. Again, the story is the same. AK is the easiest type, and then BL, it gets a little bit harder. So in my opinion, the hardest ones are down the bottom there, J and T. Now you can see why this was a S. So you can see S was pretty long. So they increase in difficulty as you move down the page. Okay? Alright, so try those for a few minutes, and then we'll open up the coursework in a moment. Question? Yeah. Yes? Say again?
Can I just discuss the answer?
That's fine now. Yeah. It's only a problem if you're talking when I'm talking.
No.
Yeah, that's a problem for me, you know.